ข่าวดีสำหรับผู้ที่ปวดข้อกระดูกเรื้อรังมานานจบปัญหาปวดข้อกระดูกถึงต้นตอในคอร์สเดียวเท่านั้นโอกาสพิเศษซื้อ3แถม1ซื้อ6แถม3ลดทันที 30% เมื่อซื้อยกกล่องจำกัดเพียง199คนแรกเท่านั้นข้อเสื่อมปวดหลังปวดเข่าเดินลำบากเจ็บทุกก้าวรักษามาหลายที่ก็ยังไม่หายเพียงดื่มโอมาชัวร์วันละ2แก้วลุกนั่งสะดวกขึ้นเห็นผลชัดภายใน 7-21 วันไม่ต้องกินยาไม่ต้องผ่าตัดประหยัดและปลอดภัยทำได้เองที่บ้านอาการปวดข้อไม่ใช่แค่เจ็บแต่ทำลายข้อต่อทุกวันหากปล่อยไว้นานอาจทำให้ข้อผิดรูปกล้ามเนื้อฝ่อรีบเดินไม่ได้อย่าปล่อยให้อาการทรุดหนักกว่าเดิมโปรโมชั่นมีจำนวนจำกัดซื้อ3แถม1ซื้อ6แถม3ลดทันที 30% เมื่อซื้อยกกล่องสำหรับ199ท่านแรกเท่านั้นโทรสายด่วนตอนนี้หรือคอมเมนต์เบอร์โทรไว้เพื่อรับคำปรึกษาฟรีพร้อมสิทธิ์โปรโมชั่นวันนี้นะครับ
ถ้าฉันรู้จักกับนมกระดูกและข้อต่อโอมาชัวร์เร็วกว่านี้นะคะฉันคงไม่ต้องทุกข์ทรมานกับความเจ็บปวดและความยากลำบากในการเคลื่อนไหวของร่างกายขอขอบคุณนมโอมาชัวร์ที่ช่วยปรับกระดูกและข้อต่อของฉันที่ทำให้ทำงานอย่างมีประสิทธิภาพและโรคเหล่านี้ก็ลดลงเป็นอย่างมากฉันขอแนะนำนะคะให้ผู้คนที่กำลังมีปัญหาเกี่ยวกับโรคกระดูกและข้อต่อลองมาใช้ผลิตภัณฑ์นี้ดูนะคะหากท่านใดมีความสนใจฝากเบอร์โทรไว้แล้วก็ทีมงานที่ศูนย์โอมาชัวร์เราจะติดต่อกับและให้คำปรึกษาฟรีนะคะช่วยให้คุณได้ค้นหาวิธีที่ดีที่สุดสำหรับสถานการณ์ของคุณนะคะนอกจากนี้กระบวนการใช้ผลิตภัณฑ์คุณจะได้รับการดูแลและสนับสนุนเต็มที่จากทีมงานดูแลสุขภาพและคอยติดตามรับฟังและให้คำปรึกษาอย่างละเอียดเพื่อให้แน่ใจว่าคุณจะได้รับประสบการณ์ที่ดีที่สุดและได้ผลลัพธ์ตามที่คาดหวังค่ะขอบคุณค่ะ
ลุงใช้ผลิตภัณฑ์นมโอมาชัวร์เนี่ยมาได้ประมาณ1สัปดาห์นะครับก็รู้สึกได้เลยนะครับว่าข้อต่อที่มือและเท้าเนี่ยมันนิ่มขึ้นเริ่มยืนขึ้นได้เองขยับจับสิ่งของต่างๆได้ลุงยังสามารถถือไม้กวาดเนี่ยนะฮะทำความสะอาดบ้านได้ด้วยรู้สึกได้เลยครับประหลาดใจจริงๆกับผลลัพธ์ที่รวดเร็วของผลิตภัณฑ์นี้ครับเทคโนโลยีจากอเมริกานะและสารอาหารเนี่ยที่ช่วยเสริมแคลเซียมให้กับร่างกายหลังจากใช้ไปได้1 เดือนนะครับข้อต่อที่หลังที่ไหล่ก็เป็นการพัฒนาที่แบบเห็นแบบผลอย่างชัดเจนรวดเร็วจริงๆครับร่างกายแข็งแรงขึ้นมากการนอนหลับเนี่ยก็ไม่รู้สึกปวดเมื่อยอีกต่อไปละมันนานมากแล้วครับที่ลุงไม่ได้นอนหลับสนิทแบบนี้มาก่อนมีความสุขมากๆเลยครับ
ยินดีต้อนรับสู่การแชร์ในวันนี้นะครับผมภูมิใจมากที่เป็นหนึ่งในคนทำวิจัยและพัฒนานมเมล็ดพืชช่วยรักษาข้อโดยตรงโอมาชัวร์สถานการณ์ทั่วโลกเกี่ยวกับข้อและกระดูกกำลังเพิ่มขึ้นอย่างรวดเร็วปัจจุบันมีผู้ได้รับผลกระทบมากกว่า 1.7 พันล้านคนซึ่งในจำนวนนี้มีผู้ป่วยโรคกระดูกพรุนมากกว่า200ล้านคนโรคเหล่านี้ไม่เพียงแต่ก่อให้เกิดความเจ็บปวดเท่านั้นแต่ยังส่งผลต่อคุณภาพชีวิตเราอีกด้วยผมภูมิใจอย่างมากที่เป็นหนึ่งในผู้วิจัยและสร้างผลิตภัณฑ์นมธัญพืชสำหรับสนับสนุนการรักษาโรคข้อกระดูกแรกของโลกที่ชื่อว่าโอมาชัวร์ซึ่งช่วยลูกค้านับล้านปรับปรุงสภาพโรคข้อกระดูกทำให้ร่างกายแข็งแรงเคลื่อนไหวได้ง่ายขึ้นตัวเป็นผลลัพธ์จากงานวิจัยหลายปีของผมและผู้เชี่ยวชาญชั้นนำของอเมริกาซึ่งเป็นก้าวกระโดดที่สำคัญของวงการแพทย์โลกผลิตภัณฑ์นมธัญพืชโอมาชัวร์เป็นผลิตภัณฑ์แรกของโลกที่ใช้โปรตีนจากพืช 100% เพื่อสนับสนุนการรักษาโรคข้อกระดูกซึ่งได้การรับรองจาก FDA สหรัฐอเมริกาโอมาชัวร์มีประสิทธิภาพในการดูแลผู้ป่วยโรคข้อกระดูกอย่างลึกซึ้งด้วยความสามารถในการลดอาการปวดข้อกระดูกอย่างรวดเร็วปรับปรุงการเคลื่อนไหวของร่างกายและป้องกันการเสื่อมโรคข้อกระดูกพรุนอย่างมีประสิทธิภาพเราคัดเลือกวัตถุดิบที่สมบูรณ์แบบที่สุดนำเข้าจากสหรัฐอเมริกาและผลิตภัณฑ์เทคโนโลยีทันสมัยที่สุดในปัจจุบันโดยกำจัดสิ่งเจือปนทั้งหมดและเก็บรักษาสารอาหารทั้งหมดไว้เท่านั้นสิ่งนี้ช่วยเพิ่มประสิทธิภาพของโอมาชัวร์ได้หลายเท่าตัวเราคัดเลือกวัตถุดิบที่สมบูรณ์แบบที่สุดนำเข้าจากสหรัฐอเมริกาและผลิตภัณฑ์ใต้เทคโนโลยีที่ทันสมัยที่สุดในปัจจุบันโดยกำจัดสิ่งเจือปนทั้งหมดและเก็บรักษาสารอาหารทั้งหมดไว้เท่านั้นสิ่งนี้ช่วยเพิ่มประสิทธิภาพของโอมาชัวร์ได้หลายเท่าตัวจุดเด่นของโอมาชัวร์คือการผสมผสานตามอัตราส่วนทองคำระหว่างนาโนเคอร์คูมิน 5% พร้อมกับส่วนประกอบอื่นๆเช่น MSM อัลวาไทด์ซึ่งช่วยเพิ่มประสิทธิภาพในการลดความแข็งของข้อกระตุ้นการฟื้นฟูและการสร้างเนื้อเยื่อเพื่อกระดูกอ่อนอย่างรวดเร็วเพียงหลังจากใช้งานช่วงระยะเวลาสั้นๆนอกจากการสนับสนุนการรักษาโรคข้อกระดูกแล้วโอมาชัวร์ยังมีวิตามินและแร่ธาตุ21ชนิดซึ่งช่วยเสริมสร้างสุขภาพโดยรวมต่อหัวใจและสมองการดื่มนมโอมาชัวร์อย่างสม่ำเสมอวันละ2แก้วหลังจาก 2-3 เดือนจะทำให้การเคลื่อนไหวสะดวกและยืดหยุ่นมากขึ้นชะลอกระบวนการเสื่อมและโรคกระดูกพรุนทำให้ระบบกระดูกและข้อแข็งแรง ด้วยความทุ่มเททั้งหมดของผมเชื่อมั่นว่าโอมาชัวจะเป็นทางออกที่สมบูรณ์แบบสำหรับผู้ที่มีปัญหาเกี่ยวกับกระดูกและข้อ ใช้โอมาชัวและสัมผัสถึงความแตกต่าง
ป้าทานนมโอมาชัววันละ2 ครั้งเช้าและเที่ยงหลังใช้สัปดาห์แรกรู้สึกอาการที่ชาที่มือและแขนหายไปการยืดและเหยียดดีขึ้นทำงานได้สะดวกขึ้นหิ้วของอะไรก็จับได้แน่นขึ้นตอนนี้ป้ายืดแขนสูงๆอย่างนี้ก็ไม่รู้สึกเจ็บอีกแล้วนะคะป้าต้องบอกว่าเห็นผลเร็วมากด้วยเทคโนโลยีใหม่จากอเมริกาส่วนประกอบทั้งหมดเสริมด้วยแคลเซียมและวิตามินและมีข้อมูลทั้งหมดบนบรรจุภัณฑ์ที่ทุกคนสามารถอ่านและศึกษาได้
นมธัญพืชโอมาชัวเป็นผลิตภัณฑ์ตัวแรกและตัวเดียวที่ช่วยรักษาโรคกระดูกและข้อได้อย่างมีประสิทธิภาพภายในเวลา 1-3 เดือนโอมาชัวแตกต่างจากผลิตภัณฑ์อื่นๆเพราะนอกจากจะช่วยฟื้นฟูปัญหาโรคกระดูกและข้อแล้วยังช่วยฟื้นฟูระบบเผาผลาญและป้องกันการอักเสบซ้ำโดยเฉพาะป้องกันโรคกระดูกพรุนเพียงแค่ดื่ม2 แก้วต่อวันเท่านั้นดื่มครบ2 แก้วในแต่ละวันไม่ว่าจะเป็นผู้ปวดข้อและกระดูกมานาน 10-20 ปีหรือเพิ่งเริ่มมีอาการเราสามารถช่วยคุณได้ครับโทรหาเราที่สายด่วนของเราได้ที่ด้านล่างนี้ได้เลยนะครับ
Marandina's production process is defined by cutting-edge technology and high-capacity machinery. The facility features quenching tanks with a depth of 9,000 millimeters and a maximum load capacity of 150 tons. The company specializes in forging shafts, flange shafts, and mandrel bushes, utilizing ultra-low emission regenerative burners. Its radial, axial hot rolling plant is one of the most powerful worldwide. Marandina operates presses up to 15,000 tons and ring manufacturing capabilities of 8,000 millimeters by 4,000 millimeters, weighing up to 140,000 kilogram. Precision cutting and machining are ensured by band sawing machines, oxygen lance cutting machines, lathes, and milling machines. Rigorous quality control and 13 advanced furnaces ensure the highest production standards. Areda high-tech equipment employs a comprehensive and advanced special steel production process, integrating forging, heat treatment, and machining to produce high-quality industrial materials for various applications. The forging process begins with the selection of high-quality raw materials, which are then subjected to precision heating in one of nearly 50 heat treatment furnaces, including trolley heating furnaces, chamber natural gas heating furnaces, and resistance heating furnaces. The company utilizes a range of forging equipment, including 5-ton electro-hydraulic hammers and rapid forging presses with capacities of 800 T, 1,600 T, 2,000 T, and 4,500 T. A key feature of Areda's forging capabilities is the GFMRF 1002000T radial precision forging machine, the world's most advanced of its kind. This machine enables high-speed, high-precision forging of carbon structural steel, tool steel, stainless steel, and special materials such as titanium alloys and high-temperature alloys. The process supports the production of round, square, flat, and rectangular cross-section products, as well as specialized components like non-magnetic drill collars. Following forging, the materials undergo rigorous heat treatment processes to enhance their mechanical properties, including strength, toughness, and wear resistance. The machining stage involves large-scale equipment, including horizontal lathes, round billet grinding machines, and deep-hole drilling and boring machines, allowing for precise shaping and finishing. The Yumuko processing line for forging shell casings is a highly automated system that ensures efficient production of steel shell casings. The process begins with the automatic feeding of steel bars into the production line. These bars are stored in a magazine designed for automatic feeding, ensuring a continuous supply of raw material. Once the bars are fed into the line, they undergo inductive heating through the BBS Brown-Boveri installation. This system operates at a power level of 1,450 kilowatts and a heating frequency of 500 Hz, ensuring the bars reach the necessary forging temperature. The heated steel bars, with a diameter of up to 130 millimeters, are then cut into appropriate lengths using the FICEP hydraulic press shear, which is specifically designed to handle high-temperature metal cutting with precision. The cut billets are then transferred to the Yumuko hydraulic press, which is responsible for the forging process. This press consists of two main units. The first unit performs compression and push broaching with a force of 630 tons and a drop hammer traverse of 1,250 millimeters. This step shapes the billets into an initial shell casing form. The second unit, which includes drawing rolls and calibration rings, refines the shape and dimensions of the forged shell casings. This unit operates with a force of 200 tons and a drop hammer traverse of 3,200 millimeters, ensuring that the forged casings meet the required specifications. After forging, the hot shell casings are organized and arranged into pallets using a robotized stacker. This step is crucial for normalizing the shell casings, which involves controlled cooling to relieve internal stresses and enhance the mechanical properties of the forged components. Following normalization, the shell casings proceed to the mechanical processing line. The first stage of machining is performed by the GF programmable hydrocopying lathe, a high-efficiency machine used for the external turning of the shell casings. This process ensures that the outer surface is smooth and within specified tolerances. The final machining operation is carried out by the final 130:1 programmable lathe, which focuses on precision turning of the inner side of the shell casings. This step ensures uniformity and accuracy, preparing the shell casings for subsequent finishing processes. The final stage of production involves the ATM, Automated Technological Module, for bending shell casings. This module starts with an automated magazine for billet charging, which ensures a continuous and efficient supply of pre-machined casings. The casings are then subjected to further inductive heating using the EMA inductive heating unit, which operates at 375 kilowatts power and 1000 Hz frequency. The heated casings are then processed in the Ucine vibrating forging press, which applies controlled force to achieve the desired bending. Two manipulators assist in handling and positioning the casings throughout this stage, ensuring precision and efficiency. Each step in the UMUCO processing line is carefully designed to optimize productivity, maintain high-quality standards, and ensure the production of durable and precise shell casings suitable for various applications. The large band saw blade production industry plays a crucial role in woodworking, metalworking, and construction, providing essential tools for precise cutting applications. As of 2023, the global market for band saw blades has been growing steadily due to rising demand across various industries. The market size was valued at approximately $1.73 billion in 2023 and is projected to grow at a compound annual growth rate (CAGR) of over 5.6% from 2024 to 2032. This growth is driven by increasing demand for processed metals and wood products used in machinery manufacturing, electronics, furniture, and construction industries. Band saw blades are widely used in different sectors, with the woodworking and metalworking industries being the primary consumers. In woodworking, these blades are essential for resawing, milling, and crafting intricate designs. The global woodworking industry has been expanding due to increased construction activities and a growing demand for customized furniture. In metal fabrication, band saw blades play a crucial role in cutting various metals, including steel, aluminum, and cast iron. The automotive and aerospace sectors, in particular, have heightened the demand for high-quality band saw blades to ensure precision and efficiency in manufacturing processes. Technological advancements have significantly improved the performance and durability of band saw blades. The development of bimetal and carbide-tipped blades has resulted in stronger and longer-lasting products. These advanced materials offer enhanced cutting performance, especially in demanding applications. Additionally, the adoption of CNC, computer numerical control technology in manufacturing has improved precision. CNC machines allow for accurate tooth geometry and consistent blade tensioning, resulting in better cutting efficiency and reduced material waste. Regionally, North America holds a significant share of the band saw blades market, with the United States leading due to its robust woodworking and metal fabrication industries. The presence of major manufacturers and a strong focus on research and development have further strengthened the market. In Europe, countries like Germany and Italy have well-established woodworking and metalworking industries, emphasizing precision engineering and high-quality manufacturing. Meanwhile, the Asia-Pacific region is experiencing rapid growth due to industrialization and infrastructural developments, especially in China and India. The expanding automotive and construction sectors in these countries have led to increased demand for band saw blades. Despite its growth, the band saw blade production industry faces challenges such as fluctuating raw material costs, which can impact production expenses and profit margins. Additionally, competition from alternative cutting technologies, such as laser and plasma cutting, presents a potential threat. However, band saw blades continue to be preferred in many applications due to their cost-effectiveness and versatility. At the same time, the industry has numerous opportunities for growth. Offering customized band saw blades tailored to specific industrial applications can create new revenue streams for manufacturers. Moreover, adopting sustainable manufacturing practices and using eco-friendly materials can attract environmentally conscious consumers while ensuring compliance with strict environmental regulations. The electric resistance welded (ERW) pipe production industry is a key segment of the global steel pipe market, widely used in oil and gas, construction, water transportation, and infrastructure projects. The global ERW pipe market was valued at approximately $35 billion in 2023 and is projected to grow at a CAGR of around 5% from 2024 to 2030. ERW pipes are produced by cold-forming steel coils into cylindrical shapes and welding the seam using electrical resistance. These pipes typically range in diameter from 1/2 inch to 24 inches, with thicknesses varying based on application. Large diameter ERW pipes are in high demand in the oil and gas industry, particularly in regions like North America, the Middle East, and Asia Pacific, where pipeline projects are expanding. China, India, and the United States are among the largest producers of ERW pipes, with China accounting for nearly 50% of global production. The U.S. ERW pipe market has grown due to increased domestic energy projects, supported by tariffs on imported steel pipes. Steel prices and energy costs significantly influence ERW pipe production. The industry has also been shifting towards advanced automation and high-frequency welding technology to enhance efficiency and reduce production defects. As demand for durable and cost-effective pipelines rises, the ERW pipe industry is expected to maintain steady growth in the coming years. The transformation and tanker transport industry relies heavily on curved and torospherical covers made from commercial steel and stainless steel for applications in pressure vessels, storage tanks, and bulk liquid transportation. These covers are categorized into various types, including torospherical, semi-elliptical, hemispherical, and dished heads, each selected based on pressure and structural requirements. Torospherical heads, the most common in industrial applications, are designed with a knuckle radius typically 6% to 10% of the dish radius, offering cost-effective pressure resistance. Semi-elliptical heads, often with a depth-to-diameter ratio of 2 to 1, provide better stress distribution and higher pressure tolerance. Hemispherical heads, though more expensive due to material usage, offer optimal pressure resistance, reducing wall thickness requirements. In Europe and North America, stainless steel grades such as 304L and 316L are preferred for corrosion resistance, while carbon steel variants like S235JR and S355J2 are widely used for cost-effective durability. These covers range from 300 mm to 4,500 mm in diameter, with thicknesses varying from 2 mm to 40 mm, depending on application needs in chemical, food, and fuel transport industries. The T-beam and I-beam manufacturing industry plays a critical role in the construction and infrastructure sectors. These beams are widely used in commercial buildings, bridges, industrial structures, and transportation projects due to their exceptional load-bearing capacity and structural efficiency. The market for structural steel, which includes T-beams and I-beams, has been expanding steadily, driven by urbanization, industrialization, and the need for high-strength, cost-effective construction materials. The global structural steel market was valued at approximately $140 billion in 2023 and is expected to grow at a CAGR of 5.3% from 2024 to 2030. The demand for these beams is particularly high in regions experiencing rapid infrastructure development, such as Asia Pacific and North America. China remains the largest producer, contributing to over 55% of the global structural steel output, while the U.S. market alone was valued at $16 billion in 2023, with an annual consumption of more than 70 million tons of structural steel. The manufacturing process of T-beams and I-beams begins with the selection of raw materials, typically high-strength low-alloy, HSLA, steel, carbon steel, or stainless steel. Steel billets or slabs are then heated to approximately 1,200 degrees Celsius, 2,200 degrees Fahrenheit, before being passed through rolling mills to form the desired beam shape. The beams are further processed through cutting, welding, and precision shaping techniques, including laser cutting and mechanical shearing. To ensure quality, manufacturers conduct various tests such as ultrasonic testing, UT, tensile strength analysis, and chemical composition checks, following international standards like ASTM A992 for structural steel. Despite its growth, the industry faces challenges such as high energy consumption, fluctuating raw material prices, and stringent environmental regulations. The energy requirement for producing 1 ton of steel ranges from 1.8 to 2.2 gigajoules, contributing to high production costs. However, advancements in electric arc furnace (EAF) technology and the increasing adoption of lightweight, high-strength steel offer new opportunities for manufacturers. Additionally, the growing emphasis on sustainability and the demand for eco-friendly construction materials are pushing companies to develop innovative production methods with reduced carbon emissions. The Acura 65L from Hedelius is a highly dynamic machining center designed for automated and precise milling operations. This machine integrates a rotating and swiveling table, allowing for advanced 5-axis simultaneous machining. The machine operates with a high degree of automation, facilitated by a connected pallet handling system or a robot, ensuring continuous and unmanned production. The machine is loaded from the left-hand side, where a pneumatically activated stainless steel loading door provides access to the work area. This side loading capability allows for seamless integration with various pallet handling or robotic systems. The automation interface is pre-configured, ensuring compatibility with different automation solutions. The loading opening has an approximate height of 900 millimeters, accommodating different workpiece sizes efficiently. The machining process is optimized with high feed and high-speed milling, improving efficiency and reducing cycle times. The slip-stick-free roller guides, in combination with direct path measuring systems, ensure precise movement along the axes. The Acura 65L maintains high circular accuracy, IT6, which is validated through the Renishaw circularity test. This test assesses the interaction between linear axes and the accuracy of circular movements, providing insights into machine precision. For enhanced accuracy in rotational movements, HEDELIUS integrates direct angle encoders within the rotational axes of the machine's components, including the swivel spindle drives and rotating, swiveling table units. Additionally, laser-based angle measurement devices can be optionally used to calibrate and optimize positioning accuracy to a resolution of +1 arc-second. These advanced measuring systems significantly influence angularity and parallelism in surface and bore machining, ensuring superior quality results. The machine's workpiece clamping system is activated via a 4-fold rotary transfer for pneumatic systems, enabling the secure fixing of components during machining. This system supports zero-point clamping elements or power clamps, ensuring optimal stability and precision. The overall setup of the Acura 65L ensures reduced production times, minimized tool changes, and enhanced repeatability in machining operations. By utilizing solid CAM programming, machining processes are optimized for precision and efficiency. The user-friendly programming interface enables the development of complex tool paths, ensuring optimal material removal rates and surface finish quality. The accessibility of the machine's front door also allows for manual single-part production when needed, providing flexibility for both automated and manual operations. Guering RF100 end mills are high-performance carbide cutting tools designed for precision milling across a wide range of materials and applications. Engineered by Guering, a leader in cutting tool innovation, these end mills excel in high-speed machining, HSM, and high-performance cutting, HPC, delivering efficiency, durability, and superior surface finishes. Their functionality stems from advanced design features tailored to optimize material removal, reduce vibration, and enhance tool life. The RF100 series incorporates a variety of geometries depending on the specific model, such as the RF100 Speed, Diver, or Sharp. For instance, the RF100 Speed features a steep helix angle, up to 48 degrees, and unequal flute spacing, which minimizes chatter and ensures smooth, quiet operation during aggressive cutting. This design enhances chip evacuation, critical for maintaining performance at high feed rates. Chip breakers in some models further fragment chips, preventing clogging and enabling deeper cuts. Meanwhile, the RF100 Diver combines milling and drilling capabilities with optimized coolant delivery, axial ducts for drilling and radial ducts for milling, cooling both the cutting edge and periphery effectively. The tools are made from high-quality carbide, often paired with wear-resistant coatings like AlCrN or Nano-A, which protect against heat and abrasion, extending tool life even under demanding conditions. The RF100 Sharp, with its 12 degrees rake angle, is particularly suited for soft, tough, or high alloy materials, offering a smooth cut and versatility across slotting, roughing, and finishing tasks. Unequal flute spacing and specialized face geometry, as seen in the 5-speed or 7-speed variants, reduce contact points, enabling low vibration machining and higher metal removal rates. The Czech Republic, situated in the heart of Europe, boasts a rich industrial heritage that dates back to the 19th century. Historically, the Czech lands were the economic and industrial center of the Austro-Hungarian Empire, producing about 70% of all industrial goods in the empire. This legacy has paved the way for a diverse and robust industrial sector in modern times. As of 2023, industry contributes approximately 30.16% to the Czech Republic's gross domestic product, GDP, underscoring its significance in the national economy. The principal industries include high-tech engineering, electronics, machine building, steel production, transportation equipment, automotive, rail, and aerospace, chemicals, advanced materials, and pharmaceuticals. The forging industry, integral to sectors like automotive and machinery, plays a pivotal role within this industrial framework. Employment statistics further highlight the importance of the industrial sector. In 2022, 36.44% of the Czech workforce was employed in industry, reflecting the sector's capacity to provide substantial employment opportunities. This translates to over one-third of the nation's labor force, emphasizing the sector's role in job creation and economic stability. The forging industry, a subset of the broader industrial sector, is essential for producing components used in various applications, from automotive parts to machinery components. While specific data on the forging industry's contribution to the GDP is limited, its integration into major industries like automotive manufacturing is noteworthy. The Czech Republic's automotive industry, for instance, accounts for 10% of the nation's GDP, indicating a substantial demand for forged components. Several companies in the Czech Republic specialize in forging, catering to both domestic and international markets. These companies are known for their precision engineering and high-quality production standards, aligning with the country's reputation for excellence in industrial manufacturing. The presence of such specialized firms underscores the industry's capability to meet diverse market demands. The Czech Republic's strategic location in Europe, coupled with its well-developed infrastructure, enhances the forging industry's accessibility to key markets. This geographical advantage facilitates efficient supply chains and distribution networks, making Czech forging companies competitive players in the European market. Additionally, the country's membership in the European Union provides forging companies with access to a larger customer base and potential for growth. Investments in technology and innovation have been pivotal in advancing the Czech forging industry. Companies are increasingly adopting modern forging techniques and automation to enhance productivity and product quality. This focus on technological advancement ensures that the industry remains competitive and can adapt to evolving market demands. The forging industry's integration into the Czech Republic's educational and vocational training systems is another factor contributing to its success. Collaboration between industry and educational institutions ensures a steady pipeline of skilled workers equipped with the necessary expertise to excel in forging and related fields. This synergy between education and industry supports continuous development and innovation. Environmental considerations are increasingly influencing the forging industry in the Czech Republic. Companies are adopting sustainable practices to reduce their environmental footprint, aligning with global trends toward eco-friendly manufacturing. This commitment to sustainability not only meets regulatory requirements but also appeals to environmentally conscious consumers and business partners. The adoption of modern forging machines has revolutionized the industry by improving efficiency, precision, and cost-effectiveness. These advancements have helped meet growing global demand while ensuring superior product quality. Increasing global demand and market size. The global forging market was valued at approximately $83.9 billion in 2022 and is expected to reach $131.5 billion by 2032, growing at a compound annual growth rate (CAGR) of 4.7% from 2023 to 2032. This growth is largely driven by the increasing need for durable forged components in the automotive and aerospace industries. The use of modern forging machines has become essential in meeting this demand efficiently and maintaining high production standards. Advancements in modern forging machines. Traditional forging processes required manual labor and had high material waste. However, modern forging machines, such as automated hydraulic presses, mechanical presses, and CNC-controlled forging hammers, have transformed the industry. Some key improvements include precision and accuracy. Modern machines utilize computer-controlled systems, reducing human error and ensuring tighter tolerances. CNC forging machines, for instance, can achieve dimensional accuracy within plus or minus 0.01 millimeters, significantly improving product consistency. Energy efficiency. Advanced forging equipment consumes up to 30% less energy compared to conventional forging methods, making them more environmentally friendly and cost-effective. Higher production speeds. Modern mechanical forging presses can operate at speeds of up to 100 strokes per minute, dramatically increasing production output while maintaining quality. Impact on key industries. Automotive industry. The automotive sector accounts for approximately 60% of the global forging market. Modern forging machines are crucial for producing high-strength components like crankshafts, connecting rods, and transmission parts. Companies using automated forging presses can achieve production efficiencies of up to 85%, reducing costs and enhancing profitability. Aerospace industry. Aircraft components demand exceptional strength-to-weight ratios. The use of advanced isothermal forging machines has improved the production of titanium and nickel-based superalloys, reducing material waste by up to 50% while enhancing mechanical properties. Defense and heavy machinery. The military and construction equipment industries rely on modern forging techniques to manufacture highly durable parts, such as armor plates and structural components. The adoption of high-speed hydraulic presses has increased production capacity by over 40% in some sectors. Future trends and sustainability. As sustainability becomes a priority, modern forging machines incorporate green manufacturing technologies, such as regenerative braking in hydraulic presses and energy-efficient induction heating. These innovations help reduce carbon emissions and lower operational costs. Additionally, the integration of Industry 4.0 technologies, including AI-driven predictive maintenance and IoT-enabled monitoring, enhances machine longevity and reduces downtime by up to 25%.